Hello ladies and gentlemen, welcome to the OmnitestCong conference and to my talk, Continuous Security Testing, 10 Steps to Move from DevOps to DevSecOps. My name is Rudolf, I'm an agile engineering coach at Raiffeisen Bank International in Vienna. Today I will show you how you can bring continuous security testing into your development cycle. The message of my talk is, build quality into your product by introducing security tests right from the beginning. I will give you a brief overview of the different types of security tests, what they can do for you, what they can't do for you, how you can automate these tests, and which tools you could use. Afterward, we take a closer look at the example of a delivery pipeline in which the different types of security tests are automatically executed in the most varied of stages. And last but not least, you get a roadmap for introducing DevSecOps in 10 steps. So, who am I? Why I can talk about this topic? I'm an agile engineering coach and guild lead of test and test automation in Vienna at the Raiffeisen Bank International. Together with my colleagues from the Agile Engineering Support Department, we are helping the RBI product teams in the area of test automation, and DevOps. In addition to my work as Agile Engineering Coach, I am the organizer of the Agile Test Automation Meetup Vienna with more than 900 members and hosting 6 times per year the Testbusters Night Vienna. Last but not least, I'm writing articles about test automation for IT magazines. So use this contact data if you want to get in touch with me. Raiffeisen Bank International. We are a commerce and investment bank for top 1000 commerce customers in Austria. We have around 1100 branches and the headquarters is in Vienna. Security testing. Let's talk about security testing. So, ask 10 people what they understand by security testing and they will get at least 11 different answers or definitions. 7 of these people say they cannot automate these tests and 5 say they can. Now, I will provide the next definition and prove that you can automate these tests in your continuous delivery pipeline. Follow me. That's my definition of security testing. I define security testing as the detection of exploitation and vulnerabilities and divided into vulnerability assessment. This is here the system is scanned and analyzed for security problems. Second, it is about penetration testing. Penetration testing means the system is analyzed and attacked by simulated malicious user. And third, it is about compliance testing, also known as conformity tests or regulatory tests. These tests verifies the conformity of a system with internal or external standards or specifications. It is estimated that 90% of security incidents are due to attackers exploiting known software bugs. Needless to say, getting rid of these bugs in the software development phase can reduce the information security risks that many companies face today. There are a number of technologies available to help developers identify vulnerabilities before they are integrated into a final software release. I distinguish 2 types of security tests. First, the functional security tests, and second, the non-functional security tests. The functional security tests a functional feature that has something to do with the security of the application. It is, as example, the login feature. or the user management or the access rights to the features of the application. In the case of non-functional security tests, we consider, for example, attacks from the Open Web Application Security Project, such as SQL injections or whether components have known security issues. As an example there, I could test the login feature with SQL injection or run a component composite analysis to check if software components with known vulnerabilities are used for the login feature. When we walk through the security jungle, sooner or later terms like SAST, DAST, IAST or RASP comes across. Let us clear this jungle in the following slides. Let's start with SAST. SAST stands for Static Application Security Testing. It is white box testing. For SAST, you need the source code, the bytecode, or the binary files, and this will be checked from inside out. You can find vulnerabilities early in the SDLC, and it doesn't need a deployed application. And it can't discover runtime and environmental issues due to the fact that you do not verify a running application. Which tools you can use for SAST? Coverity Scan Static Analysis, LGTM, or the OWASP dependency check. Now we talk about DAST, or Dynamic Application Security Testing. DAST is a sort of black box testing. For DAST, you need the running application. There you will find vulnerabilities late in the SDLC. It is employing fault injection techniques, so feeding the application with malicious data, and of course with injections like SQL injections or other injections. The tools which you are using for DAST could be the Burp Suite or the OWASP ZAP, Nessus, Arachne or Gauntlet. Let's take a closer look at the OWASP Z attack proxy or OWASP ZAP. OWASP ZAP is one of the world's most popular free security testing tool and is maintained by hundreds of international volunteers. It can help you automatically find vulnerabilities in your web applications. It is also a great tool for experienced pen testers to do manual security testing. The Z attack proxy is a free open source penetration test tool, and it is managed under the umbrella of the Open Web Application Security Project. ZAP was developed for testing web application and is both. It is flexible and expandable. At its core, ZAP is a so-called man-in-the-middle proxy. It is located between the tester's browser and the web application so that messages sent between the browser and the web application are intercepted and checked. The content then can be changed if necessary, and this changed package can then be forwarded to the destination. It can be used as a standalone application and as a daemon process. Now we come to IAST, so Interactive Application Security Testing. IAST is a term for tools that combine the benefits of static application security testing and dynamic application security testing. One of the biggest advantages of interactive application security testing is its ease of use in the development process. Introducing IST agents in the application is often more complex, but it is worth it. So, IST addressed the shortcomings of SAST and DAST by combining elements of both approaches. There you will have an agent within the application, and the agent performs all the analysis. The checks will be applied, so IST address the shortcomings of SAST and DAST by combining elements of both approaches. With IST, you have an agent within your application who will perform all the analysis. The analysis will be applied to the entire app. It's sort of runtime control and data flow information. It's configuring information, the HTTP requests and response, and the used library and frameworks will be analyzed. During this dynamic scan, the tool learned based on the reaction to test cases and information about the application. Some tools use this knowledge then to create additional test cases. IS tools can reduce the numbers of false alarms. Tools which you can use are the Contrast Community Edition. Then, let's talk about RASP, or Runtime Application Security Protection. RASP is a technology that runs on a server and is activated when the application is running. It is designed to detect attacks on an application in real time. When the application is running, RASP can protect it from malicious input or behavior by analyzing both the behavior of the app and the context of that behavior. RASP works inside the application. It is less a testing tool and more a security tool. It is plugged into an application or its runtime environment and can control the application execution. It runs continuous security check on itself and responds to live attacks by terminating an attacker sessions and alerting the defenders to the attack. And of course, RASP can have an adverse effect on the application performance. And RASP can create a sense of false security within the development team. Tools which you can use, again, is the Contrast Community Edition. Last but not least, let's talk about compliance tests. Compliance test is also known as conformance testing. It is a non-functional testing technique to evaluate and assess the system against prescribed and established industrial standards or other organizations. It will auditing the software product to ensure the fulfillment of specified standards like PCI DSS or FDA. And you can use for compliance testing open source tools like InSpec and ServerSpec. Now the question is, how does it all fit into Agile and DevOps? And the answer, security as code and DevSecOps. So the days are gone when external security specialists and auditors joined the project at the end and and delayed then the delivery for weeks. Security tests must be carried out continuously in the delivery pipeline to enable fast feedback. This is what we're talking about. So now let's take a look on our example pipeline, where we will execute then the different types of security tests in the different stages. So our pipeline consists of 5 stages. We have the development, we have integration stage, the acceptance stage, the pre-prod stage, and of course the production stage. This is where all the money comes in. So, which tests we will execute at the development stage? So, during development, threat modeling will be used to analyze possible vulnerabilities and attack scenarios, and the result of the threat modeling will then be introduced into the development of the application itself. It will be introduced into additional functional security tests and also into the task configuration. The next stage is the integration stage. So here the code from the global repository is subjected into a limited SAST check. Afterwards, the used open source components will be checked for well-known vulnerabilities through a software composition analysis. And then for quick feedback, these checks will only look at files that have changed since the last commit. And in addition, a limited functional security check will only be performed on the features affected by code changes. Okay, then we go to the acceptance stage. In this phase of the pipeline, a comprehensive SAST check is now conducted with the entire security policies. In addition, black box fuzzing is used to detect security vulnerabilities that could become a problem for the application. Thereafter, the application is tested for OWASP top 10 vulnerability via task, and the remaining functional security tests are performed. Finally, there are limited compliance checks for security, and finally there are limited compliance tests performed on the runtime environment. These compliance tests only will consider security related topics. Yes, and then we are in the pre-prod stage. So here IS analyzes the application behavior using the task attack indicators to determine whether the application would withstand the attack. At the same time, it checks whether RASP takes the correct countermeasures to ward off the attack. The application is then subjected to a final test with all functional security checks. In addition, the runtime environment is subjected to a full compliance test regarding security aspects. Yes, and then we are in production. And of course, in the production, we will also execute some sort of security tests. First, the runtime environment is subjected to a full compliance test to finally protect the application with RASP against security attacks in the production environment. And that's all. So, we are the end, and now I will give you 10 more bullet points which you can use to bring DevSecOps to life in your company. Well, number 1, Join forces with the security department. Team up with your security team. Get people on board and start your DevSecOps journey together. Number 2, support the team with a security coach. Bring a security coach to your team. The coach will help you over the first hurdles. Third, train the developer in secure software coding. So, if no defects are built in during development, they do not have to be found and corrected afterwards. Fourth, train the test engineers in security testing. So basic testing knowledge is not enough in the area of security. Number 5, train the team in threat modeling. So only if the team knows how the system can be attacked, can they develop tests for it. Number 6, introduce misuse cases or evil stories. So address the topic of security in dedicated story. Put evil stories to your backlog. This way security remains as part of the implementation. Number 7, now start with the setup of SAST. So start with the tests that come standard with the tools. These already cover a lot of the things, so later you can make more out of it. Number 8, set up compliance tests. So set up the conformance tests. Develop tests for the simplest rules like checking that only certain ports are open. Number 9, automate low-hanging fruits for functional security tests. Start by automating the testing of login functions. Every application has a login. Start here with your functional security tests. And then number 10, automate the low-hanging fruits for non-functional security tests. And again, here we are talking about the login stuff. So check the login mask for SQL injections. So these are standard which you can use with every task tool to send SQL injection into the login mask. Yes, so ladies and gentlemen, I'm done. I hope this talk was valuable, and now I'm available for questions.